Okay, we're going to do some work on recurrence relations. A recurrence relation is a sequence in which each term is a function of the previous term, so it's related to the previous term. The general form for a recurrence relation then is un plus 1 equals aun plus b, where un plus 1 is the subsequent term to un. Okay, so let's look at an example of this. A patient is injected with 160 millilitres of a drug. Every 6 hours, 25% of the drug passes out the bloodstream. Okay. To compensate, a further 20 ml dose is given every 6 hours. Okay, well, first of all, we're going to set up a recurrence relation. So, for the amount of drug that's in the bloodstream, well, 25% passes out. So we're looking to see how much remains. So that means that we retain 75% since we started with 100% and 25% passes out. Then 75% remains, and the dose that's been added in is 20 millilitres, therefore the recurrence relation is un plus 1 equals 0.75 un plus 20. Okay, so part A was to find a recurrence relation. Part B is use your answer to calculate how much drug is left after 24 hours. Okay, so first of all, U0 is equal to 160. So that's at the start of the process, the patient is injected with 160 millilitres. Okay, so U1 is equal to 0.75 lots of U0, which is 160 plus 20. Okay, so a calculation of that will give me 140. Okay, so that's after 6 hours. After 12 hours, then it's going to be 0.75 lots of not 160, but this time 140 plus 20. Okay, and that will give me 125. Now, after you've entered this data into the calculator twice, the calculator should then realise that you've got a recurrent solution, and if you hit equals again, you'll get the U3 result, which is after 18 hours, 113.75, and hit equals again for U4, and that is equal to 105.3125 millilitres. Okay, let's try an example 2. In example 2, we've got sea lice are affecting the salmon on a fish farm. It is estimated that each year 40% of the population will die. If no cure can be found, each year the farm is restocked with 100 salmon. And that is also each year. If the original salmon population is 400, so that's U0, find the remaining population after 5 years. Okay, so the population after 5 years is what I'm looking for. So, it's estimated that 40% of the salmon will die each year, and we're going to restock with 100 salmon, so UN plus 1. So 40% of the salmon are anticipated to die, so 60% of the salmon will remain. But then restocked, which means add on 100 salmon each year, gives me the recurrence relation of UN plus 1 equals 0.6 UN plus 100. Okay, so we're now going to investigate what happens after 5 years. So U1 is equal to 0.6 lots of U0, which is 400, plus 100. Okay, and that will give me 340. Okay, U2 will be equal to 0.6 lots of, this time, 340 plus 100, which will give me 304. Okay, entering the working in twice will now let the calculator know that's a recurrent solution. So hit equals again, and the calculator will then do the 0.6 times 304 plus 100 to get a result of 282.4. And then 269.44, and finally 261.664, and let's go to round that to 261 salmon after 5 years as the estimate. Okay, next question. Tom is given £50 on his 13th birthday. So that's a gift given to him. And £25 on each birthday thereafter. He invests each of these gifts in a building society. So the crucial thing is that he invests the money. The building society pays at a rate of 4% per annum, that's per year. Find a recurrent solution for the amount in his building society. Okay, well, we're looking for two things that repeat here, which is the 4% growth in his money per year, and that he's then given £25 on his birthday every year. Okay, so we can see then that U0 is the initial amount, and that is £50. The recurrent solution is given by, well, if he invests, his money it grows by 4%. So if we started with 100%, it then grows to 104%, that's 1.04 UN. He's then also given £25, so that's adding into his pot of money, so that's plus 25. Okay, the question then says, calculate what we would expect him to have by his 18th birthday. Okay, so U0 is what's going on his 13th birthday, and that's £50, so U1 will be his 14th birthday, so that's 1.04 lots of 50 plus 25. Okay, that will give me 77. Okay, U2 will be his 15th birthday, so that's 1.04 multiplied by 77 plus 25, and that will give me 105.08. Okay, so U3 will be his 16th birthday. Now the calculator will then realise it's a recurrent solution, so it's 134.2832. 17th birthday for U4, it equals again. That will be 164.654528. And finally his 18th birthday will be the fifth term, U5, and that's 196.2407091. Let's then round that to pounds and pence, so that'll be £196.24 on his 18th birthday, U5. Okay, let's try another. The population of mice at a breeding centre rises at a rate of 8% per month. Okay, so the mice population is rising by 8% per month. Each month, 100 mice are sold to pet shops. Okay, so remember, this is from the point of view of the breeding centre. The initial population is 500, set up a recurrent solution for the population of mice in the centre. Okay, so the growth of 8% will bring me up to 1.08 UN, given that we started at 100%, so a rise in 8% brings me up to 108%, that's 1.08. Right, so that's adding to the population, but 100 mice are sold every month, so that would be subtract 100. Okay, next part of the question says, how many mice will there be after 4 months? Okay, so let's see, after 1 month, so U1 equals 1.08 lots of U0, which is 500, minus 100, and that will give me 440. U2 after 2 months, 1.08 lots of 440, minus 100, and that will give me a result of 375.2. After 3 months, hit the equal sign, and that will give me 305.216, and after 4 months, hit the equal sign again, and that will give me 229.63328. So we could estimate the number of mice after 4 months to be approximately 229. Okay, let's try one final example. Each day during July, 50 kilograms of tayberries ripen. Okay, next piece of information. Fruit pickers estimate that 80% of ripe fruit is picked daily. So 80% of fruit is picked, so that's a very relevant piece of information every day. The estimated weight of ripe fruit on the 1st July is 3,000 kilograms. Okay, part A says find the recurrent solution for the weight of ripe fruit. Okay, so 80% of the fruit is picked daily. That means that 20% remains, 0.2 UN. Now, if you think about it, when fruit ripens, that adds to the amount of ripe fruit that we've got. So 50 kilogram ripens each day, so that's add on 50. That's my recurrent solution. Part B says, what is the estimated weight of ripe fruit on the 9th of July? Okay, so U0 being the 1st of July measurement is 3,000 kilograms. Okay, so U1 then will be the 2nd of July, and that's 0.2 lots of 3,000 plus 50, which will give me 650. U2 will be 0.2 lots of 650 plus 50, and that will give me 180. Okay, so if we follow that through to the 4th, 5th, 6th, 7th, 8th and 9th July, which is U8, we'll get 62.5 kilograms.